Before we talk about average speed, I want you to understand what is a uniform speed. Okay, suppose if I have a particle and that particle is covering a certain distance, maybe 20-meter distance in 5 seconds, next 20-meter distance in next 5 seconds, and next 20-meter distance in 5 seconds, right? So you can see from here that it is covering equal distances in equal intervals of time, right? So in such a case, we say that it has a constant speed, because if you take the ratio 20 meter by 5 seconds, it is going to be 4 meter per second. That is the speed, right? The speed is distance divided by time. So it is 4 meter per second. 20 by 5 is again 4 meter per second. 20 by 5 is again 4 meter per second. So in each interval you can see the speed is constant, right? So no matter how big or small the interval is, if the speed turns out to be constant, then in that case we can say that the object is moving with a uniform speed or a constant speed. If you take this interval, maybe 40 meter. So if you take this whole interval 40 meter and you divide it by 10 seconds, then of course you are going to get the same answer, 4 meter per second speed, right? So no matter how small or how big interval you take, you will always get a constant speed in the case of motion with a uniform speed, right? Okay, this is a constant speed, right? Now the definition of uniform speed is that when an object covers equal distances in equal intervals of time, it is said to be moving with a uniform speed. It is said to be moving with a uniform speed, right? Correct. Okay, right? Suppose we have a situation like this. Okay, it is covering 40-meter distance in 5 seconds, another 40-meter distance in 2 seconds, and another 40-meter distance in maybe again 6 seconds or whatever, right? Okay, so now you can see here this the distance intervals are equal but the time intervals are different. So if I take the ratio of this, it will be 8 meter per second speed for this interval. For this interval it will be 20 meter per second speed. For this interval it is 20 by 3 meter per second. So you can see for each interval the speed is different. Now such a case is called as non-uniform speed, right? Okay, now how will you define non-uniform speed? You can say the non-uniform speed means the speed is not constant at every interval of time, right? So the definition can be like this for non-uniform speed. Non-uniform speed, when an object covers unequal distances, because for uniform speed what we wrote, equal distances in equal intervals of time. Then can we write when an object covers unequal distances in equal intervals of time, in unequal intervals of time, in unequal intervals of time, it is said to be in non-uniform motion. It is said to be in non-uniform motion. Is it fine if I say like this? This is the definition. Now look at this. What the definition says: when an object covers unequal distances in unequal intervals of time. So I will give you a scenario. Okay. According to this definition, I am going to give you one scenario. Let's say, okay, this is 40 meter distance, this is 2 seconds, this is 30 meter distance, this is 3 seconds. This 60-meter distance covered in 2 seconds, right? If you find out the speed, see, all the distance intervals are unequal, time intervals are also unequal. Let's make it as 6 seconds, okay? Okay, time intervals are unequal, distance intervals are unequal. If I find out the speed, it is 20 meter per second, this is 10 meter per second, this is 10 meter per second, okay? Okay, no problem, because this is not equal, right? So all of the speeds are not equal. At this interval it is 10 meter, at this interval 10, but here it is 20. So this is a non-uniform motion. So this definition seems to be correct, right? But it is not. It is not actually correct. Why? I will tell you that in a minute. Suppose an object is moving with a constant velocity, let's say 2 meter per second, right? It is moving with a constant velocity, then of course I know it is a uniform speed. Now let's consider this interval of 10 meter. This interval of 10 meter will be completed in 5 seconds because the speed is 2 meter per second. So this is 5 seconds. And now let's say the next interval, I take it for as 5 meter, little smaller, okay, 5 meter. Now since it is 2 meter per second, okay, since it is 2 meter per second, what should be this time? That is 2.5 seconds. Now I take 15 meter distance. Now since it is a 15 meter distance, 3 times of this, then this should be 2, right? So this should be 7.5 seconds, right? Okay. Now look here. Can you see this distance interval and this all are unequal, and the time intervals are also unequal? What does that mean? This should be a non-uniform motion according to this non-uniform speed, that according to this definition. But here we know it is a uniform speed because I know if I take the ratio, I am going to get 2 meter per second. 10 by 5 is 2 meter per second, 5 by 2.5 is 2 meter per second, 15 by 7.5 is 2 meter per second. So this is in fact a uniform motion, but it doesn't look like a uniform motion according to this definition. So this definition is not correct. Okay, so how will you modify this definition? To modify this definition, what you say, if it covers equal distances in unequal intervals of time, or unequal distances in equal intervals of time. Either you fix distance interval or fix time interval. See, if I fix the distance interval to be 10 here and here also, then the time will be coming to be 5 seconds. Again, if I came to be 10 here, the time will be 5 seconds. So if I fix the distance interval to a constant, then the time interval is also going to be the same, right? Okay, sorry, not constant, same. If I make the distance interval equal, then the time interval will come out to be equal, and this will become uniform. This is a uniform motion. We will see it as a uniform motion. Okay, right? So now what I am going to do is change this definition, and I will say when an object covers equal distances in unequal intervals of time, or unequal distances in equal intervals of time, okay, either you fix time interval or distance interval, then you will understand if it is a uniform motion or not. If we fix the distance interval to be 10, then the time automatically will become 5 seconds, and you will see it is a uniform motion. But if it comes out to be unequal that time also, then you know the numerator of the speed, which is 10 meter is same, but the denominator, which is time, is going to be different. That means obviously the ratios are going to be different. Vice versa is also true. If I fix the time interval to be same, that is the denominator is same, and if you find out speed distances are unequal, that means of course the speeds are going to be unequal, and that is the case of non-uniform speed, right? Okay, so this was the definition of non-uniform speed. Now what we will do, see, about this non-uniform speed, because see, for an example, you say you go from one town to another town. Let's say your speed is varying, right? Of course it will vary because you are sometimes in a traffic, you are sometimes on a highway, and so on. So your speed is not constant, right? It is changing at different instances. Then what you will do? So to find out the speed, overall motion, how will you assess? So the answer to that is to define average speed. What is average speed, right? Suppose this is the starting point A and this is the ending point B, right? So truck is there and truck went from point A to point B, right? In between it stopped, in between it was speeding, it was accelerating, sometimes decelerating, and so on. But overall motion, overall speed, that is average speed, is defined as total distance covered divided by the total time. Okay, total distance covered divided by total time. Suppose it covers S1 distance in T1 time, S2 distance in T2 time, and this remaining S3 distance in T3 time, right? Then what will be the average speed? The average speed according to this definition is going to be total distance, that is S1 plus S2 plus S3 divided by T1 plus T2 plus T3. This is going to be your average speed, correct? Okay. Suppose there is a car which covers 100-meter distance in 20 seconds and 80-meter distance in 40 seconds. What is the average speed? Now don't do average of these speeds, okay? V1 plus V2 by 2. That is not the meaning of average speed. Go according to the definition. What does this average speed say? Average speed is total distance by total time. 100 plus 80 is 180. That is the total distance divided by total time 60. So the average speed will come out to be 3 meter per second, right? Okay. If you do averaging like your usual, then it will be 2 meter per second plus this is 5 meter per second divided by 2, which is 7 by 2 meter per second. So it is 3.5 meter per second. So this is not correct. This is not average speed. Average speed is this. Okay. Now what is the meaning of average speed, right? What is the meaning of average speed? See, suppose this is a car going from A to B, right? It took it 60 seconds to reach from A to B. Now, if it has to reach from A to B in 60 seconds, but with a constant speed, then that constant speed is going to be average speed. Okay, I will repeat. See, here this is a non-uniform speed. Suppose the car is going from A to B, it took it 20 plus 40, 60 seconds. Now in the same time interval, if it has to take a constant speed, then that constant speed is the average speed. That means, see, this is total distance, right? 180, 180. 180 meter, it has to cover with a constant speed in 60 seconds. So that means divided by 60 seconds, you will get that constant speed, which is 3 meter per second, right? That is the definition of average speed that you can see. Okay, you can see it like that way. It is that constant speed with which that object would have gone in the same time interval. Okay, that is what is average speed. In the next class, we will do more questions on average speed. Okay.